Next we have Kate Ziegler. Kate is a senior geologist at and owner of Ziegler Geological Consulting. She and her team have spent many years partnering with producers in rural communities in eastern, northeastern New Mexico, southeastern Colorado to assess and to manage groundwater resources. Thank you for participating, Kate. And I will turn it over to you.
Yeah, thank y'all for having me. I'm not going to turn my video on because I'm out in the field today. So you could just stare at the inside of my truck, but I figured that's not interesting. So what I wanted to just share with y'all today is some of what we've learned in over a decade's worth of work in Union County, which is the host for the Clayton Livestock Research Center. And when I first started working out there on starting to try to understand the aquifers that were in play, one of the things that I heard a lot was, well, we're all in the Ogallala and we're all in the High Plains Aquifer. And so there should be lots of water out here, but we don't understand why some parts of the county we can farm and some places we don't get enough water to drive a center pivot. And so what I want to share with y'all today is just some of the things that we've learned over the last decade and how the geology is very strictly controlling the availability of groundwater and how that groundwater availability is then controlling what kind of agricultural production we're doing in Northeast New Mexico and Southeast Colorado. Next slide. So when we look at Union County, and that's the green outline of our county, it's got sort of a reverse boot heel compared to the state of New Mexico. One of the things that we struggle with in Northeast New Mexico is compared to a lot of the rest of the world is we have almost no surface water. And so the vast majority of water resources that are used on sort of the Western High Plains that transition into the Rocky Mountain foreland is groundwater. And when we think about groundwater, it's an invisible resource. Like we know that it's there, but frequently we don't know how much we have, whether or not it's recharging, how deep is it, are there deeper aquifers if wells start to go dry? And so part of what we're trying to do is understand all those variabilities for a resource that's critical, but we can't just watch what it's doing from day to day. So again, when we look at Union County, you'll see these sort of yellow outlined areas. Those are the areas in Union County where we have center pivot irrigation. Sedan along the Texas Panhandle, Seneca to the north of that. The little airplane is where Clayton is. And then there's a little circle over on the west side of the county, and that's this tiny little pocket right around the community of Gladstone. And so basically what's happening is the geology under the ground is controlling the amount of water that's available for production. And the concept of we're all in the Ogallala, we're all in the same bathtub, we figured out within the first year of work in Union County, that's not actually what's going on at all. And the geology is very complicated. And so one of the reasons you can't farm everywhere, even if you wanted to, is the geology is forcing your hand in what you can and can't do. And then another question that we hear a lot about, and that is a huge concern now that we're years and years into a long-term drought cycle, is when we do get good rain or snow, is any part of that actually getting down into the groundwater system to replenish what's being used for production? And if it's not getting down there to recharge it, what do we do to manage what's effectively a non-renewable resource? Next slide. So when I used to teach at University of New Mexico Highlands, when we teach Geology 101, we always teach students that basically your rocks are all in these nice uniform layers under the ground. And so if that were the case, if we had two wells drilled a couple miles apart from each other, they should go through all the same rock units in the same order, and every one of those rock units should be the same thickness and should have the same amount of water in it or the same saturated thickness. Next slide. This is the reality, and this is simplified. So this sort of brain buster of a diagram is, it's as though I've cut a slice down into the ground beneath Union County, and it's as though we're looking into Texas. And this data comes from old petroleum wells that were drilled in the 1930s, 1940s, 1950s when they were trying to find the edge of the Dallam Basin for petroleum reserves. We also go out there and make geologic maps. We listen to what our producers tell us about how wells are behaving. We look at the chemistry of the water, and all those little pieces of data go together to put this picture together. And basically the problem is absolutely not a single one of any of the rock layers that are under the ground out there are horizontal or uniform in any dimension. So we have rock units that are folded, and that means that the rocks that were laid down over those have variable thicknesses. And then we have rock units that have different rock types even within them, like the Morrison Formation. It's mostly mud. Probably 75% of the thickness of that unit anywhere you drilled is just going to be mud, which isn't going to give you very good water. But every now and then you get lucky and you hit a little pocket of gravel, and that'll give you 20 to 30 gallons a minute for a little while. And then we get into the question or the problem of the Ogallala Formation. And this idea that we hear of oceans of water under the high plains of the United States, the Ogallala itself is the remnants of giant alluvial fans that shed off the Rocky Mountains onto a landscape that was already highly eroded. So you end up with sand and gravel that's very, very thick and has lots of good water in it, where you have old valleys that got filled in with that gravel and sand. And so depending on where you put a well, and you can see the 3 different wells on this diagram, each one of them encounters a different suite of rock types. And so you can have 2 wells that are half a mile apart. One will give you 500-600 gallons a minute and you can center pivot irrigate off of it, but you can go half a mile, sometimes even less, and end up in the Morrison at the same depth and have no water, or maybe 5 gallons a minute, maybe 20 gallons a minute. And so then your hand is forced and you're pushed back into doing either dry land or range production. And the one complicating factor I did not even attempt to show in this diagram are the volcanoes. New Mexico's got a ton of volcanoes, and everywhere you have a volcano erupt, that disturbs the geology even further. Next slide. So this is another slice through the ground, and this is actual data from petroleum well logs that were drilled in the 30s through the 50s. And it ranges from north on the left side of your screen to going south on the right side of your screen. And there's Clayton with the red star. And this is basically as though I've cut a slice with a giant bulldozer through the ground and I'm looking into Texas. And you'll see a few different features here. The yellow line is the bottom of the Ogallala, right along the Texas state line going through Clayton. So when we talk about the center pivot at the research center, the fact that y'all can have 700 plus gallons a minute is because the research center is sitting over one of these little Ogallala Paleo-valleys. And so you have enough saturated thickness and good enough conductivity for water to flow easily through that. The blue line is the top of the Morrison Formation, and you can see that it comes right up to the surface as you head towards the dry Cimarron, and also as you go south towards the community of Narravisa. And so again, just reiterating this problem that wherever you drill a well, you're probably going to encounter something different than the wells that you already know about. And so for the research center, it's sitting over one of these little pockets of water. But one of the problems that we found with a lot of these deeper Ogallala wells is they're not receiving modern recharge in a way that's volumetrically significant. And so the amount of water that gets drawn out for agricultural production is not being replaced by any rain or snow that we get. And in our decade of work with Union County, many of the producers to the south around Sedan have actually altered their crop management techniques to take into account the fact that their water is not renewing. Next slide. So when we look at the Clayton area aquifers, just to kind of sum up what's a lot of complicated data and trying to sum this up in less than 10 minutes, basically throughout the Clayton area and most of Union County, we see a zone of shallow groundwater, a zone of intermediate groundwater, and a deeper groundwater component, these don't always match exactly to any particular aquifer. So you can have a shallow Morrison well and a deep Dakota well. Generally, only shallow wells, ones that are less than 50 feet to water that are near drainages, get any of that rain or snow when we do get it. And we haven't gotten very good rain or snow for a very long time. And we are starting to see significant impact from that drought on decline in water tables throughout the region. And then on sort of a final note is we get a lot of people who get upset and worried that, well, that guy's using center pivot over there and I've got a livestock well, and I'm sure that every time he turns that well on to water his crop up, that he's taking my water and my well declines. As y'all just saw, the geology is complicated enough that frequently if a well is declining, it's not always corresponding to center pivot irrigation usage. And so being cautious of thinking about how wells are interfering with one another is always something to be kept in the back of our mind. I can't remember if I have one more slide.
Apparently not.
Okay, so that is the summary of the very complex story of the Clayton area aquifers.